Okay, this is Student Notes 11.2, Arcs and Chord Relationships. Okay, so we've just started our unit over circles, so one of the things we need to talk about are the different types of arcs that are on circles. The first thing we're going to talk about is the Arc Addition Postulate, which is kind of just like the segment addition postulate, which was like part plus part equals whole. Same thing here with arcs. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So the measure of arc ABC, so let's see, where is ABC? Arc ABC, so A to B all the way to C. That big arc right there is made up of two smaller arcs. And those two smaller arcs are, the first one is from A to B, and the second one is from B to C. So we would say that arc AB plus arc BC make up the whole arc of ABC. Okay? So the measure of a blank arc is equal to the measure of its blank. Okay? So this arc right here from A to C, so this is a minor arc. It's smaller than 180 degrees, is equal to the measure of its central angle. So whatever this x is here, let's say x was 60 degrees. Just made that up. Then the measure of this arc right here would also be 60 degrees. They're the same. Okay, you always name a minor arc with two different points. In this case, we have A to C. Those are the 2 points we're using. So the name of the minor arc in this picture is minor arc AC. Okay? Let's look at this next picture. The measure of a major arc is equal to 360 degrees minus, it's either, you could either say it's minor arc or you could say the inscribed angle. So basically you take the whole thing and subtract the minor arc and you get the major arc. Or you take the major arc and or 360 degrees and subtract the major arc and you get the minor arc. Okay, a name of a major arc, you name a major arc always with 3 points, not 2 like the minor. And the name of the major arc pictured here is, well, A to C is the minor. So the major would be the one that's greater than 180 degrees. So that would be from A to D to C or from C to D to A. So we'll do A, D, C as the major arc. The semicircle is always 180 degrees because a semicircle is half of a whole circle and a whole circle is 360 degrees. And you always name semicircles with 3 points as well, just like how you would name a major arc. It has 3 points. And a whole circle is 360 degrees. Okay, with those things in mind, let's go ahead and look at example 1 and example 2. Example 1, find the measure of arc GH. Okay, well, where is arc GH? Well, here's G, here's H. Okay, remember that this arc right here, whatever it is the exact same degree as its central angle. So whatever this angle here is also the same as its arc. Okay, well, we can find out what this angle is here because this is a straight line and it goes through K, so it's our diameter. From F to J is a diameter. That means that all of these angles put together have to equal 180 degrees. So if we added the 65 and the 63 together, we get 128. And then if we subtract from 180, so you take 180 and minus 128, it'll leave you with what x has to be. And so 180 minus 128 is 52 degrees. So if this is 52 degrees, then its arc is also 52 degrees. So the measure of arc GH is 52 degrees. . Okay, let's look at example number 2. find the measure of arc BD. Okay, well here's B all the way, I'm not doing a very good job of that, all the way over here. Let's try it again. B, nope, didn't work. Nope, nope. There we go, that's a little bit better. All right, so there is arc B to D. Okay, so what do we know about this circle? Well, we know that this central angle here is 97. And also this central angle here is vertical to this angle here. So those two angles, we know that vertical angles are always congruent, so these two angles have to be 97. Now remember, we're looking for the central angle of B to D. So this angle plus this angle here will give us what this arc has to be. Well, if this angle is 41, then this central angle also has to be 41. So because our arc stretches from B to D, then these two angles are the same things as these arcs. So this is 41 degrees and this is 97 degrees. So the whole arc would just be 41 plus 97, which would be 138 degrees. So the measure of arc BD is 138 degrees. Okay, we're going to go ahead and save example 3 and 4 for class. So go ahead and turn your paper over to the other side. Okay, as we look at the back, we have a couple of things we need to talk about: congruent arcs, chords, and central angles. So if you have congruent central angles, which just means that this angle here and this angle here are congruent, then you also have congruent chords. Okay, so that means that this chord right here from B to A is congruent to this chord right here, C to D. Okay, so now that we have congruent chords, we can also assume that we have congruent arcs. Okay, so because we have these congruent chords from A to B and from C to D, then we can say that arc BA is congruent to arc CD. Okay, and then this last one says because we have the congruent arcs, then we can assume we have congruent central angles. Okay, so our congruent arcs were from B to A and from C to D. So because we have those two congruent, we can also say that our central angles are congruent as well. Okay, so with that in mind, let's look at example 5. Use the figure to the right over here to answer the questions below. A, which two chords are congruent? So we're looking for the markings that are the same. This has 2, this has 3, this has 1, this has 1. So these two have the same amount of tick marks. So chord AB, which is just a line segment, is congruent to chord CD, or line segment CD. Okay, so if those two chords are the same, then which two arcs are the same? Well, remember up here, if we have congruent chords, then we also have congruent arcs. Congruent chords, congruent arcs. So if line segment AB is congruent to line segment CD, then arc AB is congruent to arc CD. Okay. What are the measure of these arcs? Okay, well, we don't know much about the arcs right now except for the fact that they're the same number. But we do know that the other two arcs in our circle are 20 and 220. We also know that a whole circle is 360 degrees. So what we can do is we can take 360 degrees and subtract the two other arcs. Well, 220 and 20 is 240 when you put them together. So 360 minus 240 just gives us 120. So that means we have 120 degrees left for both the AB arc and the CD arc. Well, they're each the same, so we're just going to cut 120 in half. So each one of these arcs is 60 degrees. Okay. We're going to save examples 6 and 7 for class. Let's go ahead and look down at the bottom of the page. In a circle, if a radius or a diameter is perpendicular, keyword, to a chord, then it bisects or cuts in half the chord and its arc. Okay, so here is our radius. Here's the chord and it's bisecting. So it's cutting the chord in half. So each one of these would be congruent. So since AB is perpendicular to CD, that's why it has a right angle right here, AB bisects, not only does AB bisect this chord here, but it also bisects its arc. So it's cutting this arc, CD, in half. So it's also saying that arc CB is congruent to arc BD. Actually, I'm going to go ahead and reword that. It's cutting in half. AB is cutting in half. It's bisecting. AB bisects CD, line segment CD, and arc CD. And so what it's doing is it's making, since CD is being bisected, it's making CB congruent, arc CB congruent to arc DB. Okay. All right, we're going to save example 8 for class. The last one we're going to look at is number 9. Find the length of the radius R to the nearest tenth. Okay, well here's our R. From K to L is our radius R. And we see here that this line right here, this dotted line, is a 3, and it's making a right angle. So that means it's bisecting our chord. And we just learned that it bisects our chord. That means that each side of our chord is congruent. So if the whole chord is 14, then this has to be 7. So basically we have a right triangle that looks like this. 3, 7, and we don't know its radius. Also here, this is the hypotenuse. So we could easily use Pythagorean theorem to find the radius. The radius is your C value because it's across from your right angle. So our A value we could say is 3. Our B value we could say is 7, and we don't know our C value. 3 squared is 9. 7 squared is 49. And 9 plus 49 is 58. So, to find what C is, or in this case the radius, we would have to square root it. The square root of 58 is 7.6157, and it says to round to the nearest tenth, so only one decimal place. So 7.6 will be our radius of this problem. And I will see you guys in class tomorrow.